The new Petrobras production and storage floating units, the FPSOs P43 and P48, have the capacity to produce 150,000 oil barrels per day. Located at Campos Basin and operating at the Barracuda and Caratinga fields, platforms P43 and P48 represent an increase of approximately 20% in the national daily production. These units are found at the end of a gigantic project, responsible for raising to the surface the oil found at more than 1,000 meters of water blade on the ocean. In addition to storing and transferring the oil, a FPSO has a function to process it, removing water and gas from the oil found in the reservoirs. We shall now consider the main structures of the P43 and P48 FPSO's process plant. Oil is raised from the ocean bed to the surface through special pipes called risers, built to resist pressures exercised by a huge water column. Risers arrive at the platform and are connected to the manifolds, sets of valves and control instruments required to provide flexibility to the operation of the platform. In the same module as the manifold, we find the pig launchers and receivers, essential for the maintenance of raising lines and submarine equipment. Pigs, through a mechanical action, clean the lines, removing paraffin and other substances adhering to the internal walls. The oil getting to the manifold is aligned to main ducts called headers, which are responsible for the oil gathering deriving from the several oil-producing wells. Thus, the oil is guided to the preheaters, where energy that could be wasted is recovered, increasing the oil temperature in approximately 5 degrees centigrade. Then the oil goes to the production heater. Here we find heater exchangers where hot water under pressure will run through the exchanger internal structure made of several small caliber pipes, and the oil will occupy the shelf involving them, thus maximizing the exchange of temperature between water and oil. At a temperature of 180 degrees centigrade, water transfers latent heat to the oil, warming it up to a temperature of 80 degrees centigrade, optimum temperature for the separation process. Now the oil is ready to enter the production separator. Also known as the first stage separator, this vessel operates under the control of some variables such as pressure, temperature, level of oil-water, and gas-oil interfaces. By controlling those variables, providing the pre-established time of residence in the project, and using the adequate demulsifying agent, we assure that the oil, water, and gas phases are individually treated in the subsequent systems and conformed to the more strict quality standards required. From this moment on, we shall follow the three-element phases separately, starting with oil, which now goes to the oil treatment device. This equipment has the objective to confirm the BSW contents, that is, water and sediments, and consequently the salt content in the oil. Electric field is used as a means to demulsifying. Electric field of alternating current causes the water droplets to stretch in its direction, creating an attraction force among the close droplets, weakening the natural emulsifying pellicles, inducing coalescence, and later decanting the water drops. The oil leaving the oil treatment device is cooled in a heat exchanger parallel plate type, which the cooling fluid is seawater. After cooling from 80 degrees centigrade to about 53 degrees centigrade, the oil goes to the atmospheric separator, which is the last stage of oil stabilization. Simultaneously, recovery of the gases separated in the vessel is carried out, maximizing gas production. Finally, the oil goes to the cargo tanks of the ship. Oil is distributed through the several tanks in order to maintain the vessel's stability. After approximately 7 days of production, the oil accumulated in the platform tanks is transferred through pumping to an elevator ship. This operation is called offloading. Offloading can be carried out through the stem as well through the stern of the FPSOs. There, too, the platforms have available pumps with pumping capacity of up to 10,000 cubic meters per hour. This operation lasts, in average, 24 hours. Now that we have followed all the oil treatment processes, we will go back to the production separator to follow up the stages of gas treatment. Gas needs to be compressed and dehydrated to be utilized. After leaving the production separator, the gas carries a quantity of liquid that has to be removed before getting to the compressor. 2 vessels called safety gas knockout drums execute the role of separating liquid from the gas. Both have the capacity to operate with 3 million cubic meters per day of gas and separate up to 354 cubic meters per day of liquids. These vessels minimize the possibility of liquid being dragged to the compressors, preventing damages. The compressor is an operating machine. That is, it needs contribution of energy to work. In the case of P-43 and P-48 platforms, the compressors are activated by high-power engines with variable speed drivers, which are devices to control compression capacity. Each of the first compression stages is composed of a gas cooler and a vessel to separate the condenser, which is formed after the gas is compressed and cooled, and this condensed is recycled to the previous stage. Gas from the second stage of compression, after being cooled, goes to the tower of gas dehydration known as TEG tower. It is a tower to absorb water by using TEG triethylene glycol as absorption fuel. This operation is maximized by the reduction of temperature and increase of pressure. The whole system of the tower control was designed so that the gas flowing from the TEG tower is sufficiently dehydrated. Leaving the TEG tower, the gas enters the third and last compression stage, where discharge pressure reaches approximately 180 bars. Now that we have been through all the processes of gas treatment, we return to the production separator to follow up the treatment stages of the water produced. Oily water at 80 degrees centigrade, coming from the 3-phase production separator, enters the hydroclone battery, where part of the oil is carried by the water is removed and recycled for the oil treatment system. Then, the water, almost free of oils and grease, goes through the oil preheater prior to entering the floating machine, which is the equipment responsible for the final polishing of the water produced. Prior to being thrown on the sea, the water produced is stored in a structural tank by the FPSO. Now that we have gone through all the treatment processes of the water produced, we will mention a process which is not directly related to oil: treatment of the water injected. All the development project of the Barracuda and Caratinga fields is based on the maintenance of the pressure in the reservoir through water injection. Water for injection should be specified complying with rigid quality standards before being injected in the reservoir. The process of water injection starts with sucking water from the sea with lifting pumps. Prior to entering the deaerator tower, the water goes through filters to remove particles larger than 80 micras. Then, at the deaerator tower, the seawater is subjected to gas stripping, which is a process to mechanically remove oxygen. Simultaneously, an oxygen scavenger is injected, sodium bisulfite, which aims to chemically remove the oxygen